people are planning on doing, and some futures, and then we'll open up for a few questions if there are microphones in the audience. Otherwise, you'll have to speak loud. There are 2 mics. I don't see them actually mounted. There's no microphone there.
There are mics, you just can't see them.
There are mics that we can't see. Okay, I'll believe you. Okay, hi, mic guy.
Oh.
All right, exchange points. These are places to exchange traffic. They, in every case, are a shared media. Sometimes they're multilateral things where you got lots of people playing the game. A lot of times they're bilateral. A pathological case is a point-to-point link between 2 service providers. That's sort of private peering for you. But those are generally not particularly interesting, except in the case where you really need to optimize for efficient use of bandwidth between 2 particular service providers. And so we'll have to go a little bit faster so this doesn't blank out. Technologies, there are things like layer 2 media. This is stuff like mesh in a box, where you have sort of a switch, a gigaswitch comes to mind. Distributed, these are things like frame relay clouds, ATM clouds, those kinds of things, or point-to-point links, HDLC circuits between 2 different service providers. Another model is a layer 3 media. Kix did this long time ago. The only other public exchange that I know of that pretends to be open is the Singapore exchange, which uses layer 3. They push everything up where you actually inherit policy from your neighbors. A lot of private exchanges, the Cable and Wireless Internet Exchange Project, Savvis, and the like, do things at a layer 3 exchange for inheriting policy, because they all share the same AS. Problems with exchange points, you end up with these things called speed mismatches. I call them that. The problem is with the line cards. Line cards have been increasing their capacity since the last 4 years or so, from, say, T1 and Ethernet rates to gigabit Ethernet OC192 rates today. The problems that we have are that those are as fast or faster than a lot of the backplanes and the switching gear. And so you don't have the ability to actually run full rate across exchanges. This encourages people to go to private exchanges where they don't have to compete for backplanes bandwidth. Another problem is sort of the control freak problem. Dollars control equipment options. A lot of people could have migrated to faster exchange technologies if there was cost-effective equipment available at the time. A lot of the problems you see today at some popular exchanges have a whole lot to do with what equipment is available, what works, and that really is driven by what people are willing to build at what price point. Any telcos here? Any representatives of those telcos here? Anybody that wants to pretend to be a telco? It's all your fault, Steve. It's all your fault. Telcos have a vested interest in how things are deployed in the Internet. Internet technologies traditionally have been media independent. Things will run over wire. They'll run by carrier pigeon. I've seen proposals for running IP over seismic waves. You don't have to run over telephone company infrastructure, but everybody does because it's cheap. Some other things with exchange points, you can do this in a number of different ways. The popular ones have been unicast, so you basically throw things up and everything runs unicast the way the way God intended. There's going to be some discussion, and there are people that are looking at multicast exchanges, and those tend to be bags on the side of unicast exchanges for now, because we don't quite understand them. And then there is quality of service or brokered bandwidth exchanges, and these Hopefully we'll get one or more of you to talk about those kinds of things. Instrumentation at exchanges. Casey would love for everybody to instrument their exchange. Yes, you would. Don't shake your head no. Because that's really now the place where people can actually get decent measurement. Measurement on backplanes tends to be problematic. Where traffic actually crosses between administrative bounds is interesting. And the way people do instrumentation, they either put probes down. These are for doing things like packet analysis. This gives sort of a neutral viewpoint of what's happening on the switch media, the switch mesh that all these packets are flowing across. There are the counters that count bits, and they count dynamic changes in traffic flow. Other instrumentation are things like arbiters, route servers, route reflectors. They help in dispute clarification, and those tend to be used by the people that are on the immediate exchange. There are some ways you can actually make those useful for other people. Looking glass stuff shows up at these kinds of things. Thanks, Ed. And so we're going to start with panel discussions. These guys are going to talk about their various exchanges, what they've done, what they're planning on doing, and what might be useful in the future. And Chris, are you ready to start?
It's not being plugged in, unless you have it on your...
I don't.
Okay.
Well, I do, but it's not useful.
You don't have to...
No.
Early.
Okay, I'm Chris Caputo with Allsopia. I'm a volunteer for the Seattle Internet Exchange. It's an exchange that's been in existence for about a year and a half now. Got 13 connected, following listed, 3 pending, and since I've been at this NANOG, I'd say about 3 or 4 more pending. A number are nationals, and then many are local providers in the Seattle area. It's in the Weston office building, which is the Teleco Melka, or at least one of them in the Northwest. We're actually using donated or contributed Catalyst equipment right now. Connect speeds are 10 and 100 megabit Ethernet. Migration plan prior to yesterday was multiple Catalysts chained by gigabit Ethernet, but it looks like someone's might be contributing a Cat 5000 for us. Pairing is bilateral. There's no MLPA. Amazingly, it is a cooperative effort. On the web page, you can see some of the contributions that have been made by different participants. No route server at this time. No instrumentation. This is an example of my company's traffic over the last, since 1097. I have the MRTG backwards from how most people do it. But it's an example of, it's bytes per second. It's an example of how you can get multiple T1s of savings in cost by just a local exchange like this. And that's it.
Can you go ahead and move those?
Yeah.
Great. Okay. What I'm going to talk about is some issues around running production multicast at inter-exchange points. Hold on, I'll go ahead and tell you, Linda. So in talking about production multicast, we could take a look at historically what happens. Typically what happens if you're going to run multicast in an inter-exchange point is you would receive a DVMRP tunnel or something like that from a dedicated multicast router that's actually physically located at the exchange, or maybe it's a couple hops off of the exchange point. And then you would share a global DVMRP routing table to do multicast routing across that tunnel and distribute that internally. So while that's been extremely successful in demonstrating the viability of multicast as an internet routing protocol, it's not scaling up to meet the production needs that most people are trying to deploy right now. So then what are the objectives that we should be looking for at exchange points in order to support production multicast? I'll talk a little bit about that, some of the design issues, and then a little bit about at least one exchange that is actually running production native multicast and these design objectives. So ideally what we would have in an exchange is support for native multicast. And of course, ideally in the spirit of multicast, we'd be able to send only one copy of data across any particular link. In addition, we'd like to be able to use an EGP for interdomain routing like we do in unicast, and then to use a variety of IGP protocols in intradomain like we do in unicast. So a number of exchanges have moved to try and meet these production design objectives. And we'll take a look at a couple of the design elements now. All right, the first thing is route exchange. Obviously, the preferred choice for EGP would be to use BGP if you're multicasting across the same interface that you would unicast across. Or if you're not, you could take advantage of the multi-protocol extensions to BGP4+, so that you can specify a different multicast routing information based to RPF across a different interface. So that's the route exchange protocol that's being used right now is BGP or MBGP. The second thing that we need to do is establish a multicast tree building or multicast forwarding protocol. And PIM is being used at these exchanges in order to take advantage of BGP or MBGP, but also it allows for use of whatever internal IGP is being used by the various peering providers there. Now, initially, dense mode is being used on the interconnects, and I'll talk a little bit about why that's happening. But because it's a flood and prune protocol, ideally what will be used is PIM sparse mode at the interconnects. So that brings us to the third design element. So here's the issue. If you're on an exchange and you're peering across this exchange, one of the things that you need to do if you're a sparse mode environment is to be able to learn about active sources in your peering partners. Now currently what you can do is you can co-locate your rendezvous point at the exchange. The exchange is in dense mode, and data from those peering partners is flooded across the exchange, thereby providing information to your RP about active sources in your peers. But since you're flooding the data, this is a fairly inefficient way of learning about active sources in the internet. Ideally, what you'd be able to do is simply have your peers send you a list of active sources, and then if you have interested receivers in your network, you can go ahead and have them join straight back. So ideally, what a number of exchanges have started to do is to set up NMSDP peering sessions. The exchange then is put in sparse mode, and information is exchanged that way. In terms of the media, of course, in order to meet the native multicast objective, a number of the exchanges have moved to set up a dedicated FDDI concentrator. And this is a fairly simple approach to being able to do native multicast. Providers who are interested in doing multicast across that exchange just simply get another FDDI port they attach to the FDDI concentrator. Now what happens is since the interface that they're going to do multicast from is different than the interface that they do unicast from, they go ahead and run MBGP so that they can specify which prefixes they're going to exchange from multicast across that multicast internet exchange. So let's take a look at just a simple topology diagram from one of the exchanges. This one happens to be at Ames Research Center in Moffett Field, California. And you can see here two MBGP peers. They're dual homed both to the unicast exchange, which in this case is either the Fix West facility or a portion of the May West facility. They're also homed then to the multicast exchange. And because they have the two separate interfaces, they use MBGP to specify prefixes to be used in the RPF check for multicast. The way that at Ames that you would operationally attach to this is you simply obtain an additional FIDI interface. You contact Ames, they connect you up to the FIDI concentrator, and you go ahead and contact your peers like you would for unicast to set up MBGP peering. And right now we're seeing anywhere from 5 to 25 meg of unique multicast traffic across this particular exchange point. I think later in the day there'll be a discussion on actual experiences from various ISPs on setting up MBGP and deploying multicast, so you can probably address some of those questions then.
My name is Nielsen. I represent the Utah rep out of Salt Lake City, Utah. Just a question before we begin here. Just wondering, how many of you connect to local exchanges outside of the traditional maze and nav set up by it? Let's see, so there's a few of you here. Okay, excellent. The term rep actually came from our friend Dave. He out of Phoenix. We adopted it very quickly and saw a need to put a regional exchange point in Salt Lake City, Utah. We're not exclusive to the name. Anyone has the right to use it, so no problems on that. I want to go over our history a little bit. In 1995, there were three different providers in the same building, and each provider was using a different carrier at the time. So our round trip times were 100 milliseconds plus. We were sending news feeds to each other because we knew each other, and there was a discussion: is there a better way to do this? And that was coming up with the rep. The next step of getting the rep going was convincing the other providers that it's a good thing. There seems to be a distrust sometimes among internet providers about is connecting together at one single point a good thing, and sharing routes. In my opinion, it is good. Today, the Utah rep includes 10 providers. The state of Utah has their whole network on, which includes all of K through 12 and universities, and basically every major provider in the state of Utah. The rep, the way we set it up was not one company owns the rep. It was a conglomerate of people. We have It's a membership, and we come together and we vote on different issues. If we decide that we want to go in this direction, then as a group we decide to go in that direction. In the beginning, our connectivity started out as an intellectually challenged hub. And that was back in '95. We didn't feel and have the proper funding to purchase a switch. Then moved to a 10 meg Cisco Catalyst switch, and is currently running on a Catalyst 5505. We do layer 2 switching. No layer 3 on that, as Bill pointed out. There's only 2 others. All providers of the Utah rep connect at 10 meg or less. The only one that actually has the ability currently today is the University of Utah, or the Utah Educational Network, as we have moved the rep to their location. Most of them bring in T1s, 2500s, 2600s, less than 200 routes total on the rep. We do require that all members, when they do bring, they have enough bandwidth available so that their circuits are not overloaded. There is a looking glass located in the URLs there. Once again, these will be on the web, so if you don't have time to write it down, we will have it on the web for you. Future plans for the Utah rep: adding cache servers, news peering servers, more bandwidth for the providers when more providers come on, and more peers. We have a few other companies given their, I guess, word or saying that they will be connecting to the rep soon. We are not planning to move to any other fabric that is ATM, frame relay, considering to stay with layer 2 Catalyst 5505. But once again, this is a conglomerate of people. It can change in the future. Attachment requirements, one of the major things we look for is a clue. It seems that there's a few providers out there who think they know what BGP is, but really don't understand it. A router capable of doing BGP, like I've said before, there's 200 some odd routes, so we're not looking at a beefy Cisco, a sandbox. Currently, most members do filtering based on AS path. Others do filtering based on your IP addresses. So when you do connect to the rep, you need to send a list of all your IP addresses to the mailing list, and then the different groups will filter either by AS path or IP address. And we do listen to meds. So if you came and decided you want to send meds in case you're appearing in other places, that is a possibility. We do give out public stats, and this is public stats for each provider, are located on the exchange on the web page. Bill, if you want to just quickly put that up. These stats, this was a printout of yesterday, so as you can see on Sunday it's not as active, but we're peaking at about 5 megabits per second. On the peaks, average around 2.5 megabits. Okay, go back. And also on measuring, if there's anyone who would like to do any statistics or counters or anything at a local exchange points, we will allow you to do that over the rep. You just send me an email. I don't have it on here, but it will be on the web page, and we'll allow you to come in, pull some SNMP data without any problems. Most providers report that approximately 10% of their traffic is sent locally. A lot of that traffic could be included. Newspapers, there's a few local newspapers that get read pretty heavily in our area, and they're connected via the local providers and then via the rep. Usenet, of course, that's our distribution channel for porn, wares, and MP3.
Can you break those out?
What? Oh. Once again, we don't know. We haven't. Future measuring. Once again, we can look at different ones. Bill asked if we had anything broken out, and the question is not at this time.
I just want to know how much is MP3 versus
Porn?
the other.
It's probably a tie.
Okay.
Advantages. Of course, everyone understands that a local exchange point keeps local traffic local. If there's problems with the larger maze, NAPs, we don't see them locally. And then we can share local services, news feeds, caching peers. A lot of times, because you are so close to each other in distance-wise, you know your neighbors, so it's easier to call someone you know and say, hey, could I exchange a news feed with you? You're both connected at the rep. You share news feeds. Disadvantages, fewer providers, less advantage. I mean, that's obvious. The more providers that join on, the better the exchange point becomes. And once again, not enough local clue. We decided to add a little bit here, advantage to larger providers, especially on something like the Utah rep. And of course, the same as listed earlier. Local traffic never leaves the area. And the ability to advertise local routes and not all routes. So let's say you were a large regional provider and felt that, well, you'd like to go to the exchange, but your backbone is larger than the other providers. Well, you could go to the exchange, send only your local routes from that city, and then it's on an equal footing. And then for those marketing people, it's a marketing opportunity because you know the providers, you know who they are, and you have a relationship with them already. Once again, some of the disadvantages would be more connecting points to worry about, more peers to turn up, and are they my equal? By the end of today, the notes and all the links to the sites will be put up on the web, and this will be the URL. one thing I didn't mention here is the Utah rep is a multi-level MLPA, multilateral peering agreement. So if you come, be ready to play with everyone. Thanks.
Dan, you got that?
Must be better than one. Cool. 3 mics. Wait a minute, now I can't see it. Oh, cool. Someone else's problem. First, thanks to Bill Manning for roping me into doing this talk. My name is Dave Siegel. I am the MPICS Operations Manager, also a Network Architect for Frontier Global Center. And I have to give the disclaimer, Frontier Global Center is not affiliated with the MPICS other than as a participant, and is no way responsible for the ongoing maintenance of the exchange. So if you're experiencing routing problems with another member at the MPICS, please don't send them to our NOC. The MPICS is a local exchange for the Phoenix area. It's located physically at Genuity's data center in Phoenix, Arizona, and administratively.
I don't understand why it's not. Are you sure you're solid back here with us?
I would think so.
Oh, I'm sorry. I thought you were.
I can't see that one anyway. And it's administratively controlled by the Arizona Internet Access Association, which I'll talk more about later. The exchange was formed in 1995. It's the second exchange that I started, the first of which has been turned down as of last year. We started it in the most successful way known to start a local exchange. We got all the ISPs in a locality in the same room, gave them gourmet cookies and lots of soda and coffee, and talked about the benefits of having a local exchange and who would run it and who wouldn't run it and those kinds of things and what kind of technology we wanted to use. And it was decided that a nonprofit organization should maintain the administrative control so that everyone had a sense of ownership in the exchange itself, which has been shown to be the most successful way to do that. There was already a nonprofit organization known as the Arizona Internet Access Association, which was already a collective group of ISPs across the entire state, mostly a trade organization, and it was decided we'd go ahead and piggyback the MPICS on top of the existing nonprofit org. Genuity donated the hardware for the exchange, courtesy of Rodney Jaffe, and I decided to donate my technical expertise to make it work. If you want to attach, you have to be a member of the organization. Membership fees are $100 a year. And once you pay your dues, connection to the exchange is free of charge. We're using a Catalyst 5000 for our primary platform. We have several providers coming in with dedicated 10-base-T, FDDI, and 100 meg connections, as well as a Cisco 2501 with the U.S.-to-West frame cloud where providers can bring in frame relay PBCs to their existing frame clouds to exchange traffic. From a logical standpoint, every provider peers with the Cisco 2501, sends it all of their local and customer routes. The only purpose that this serves is it builds a forwarding table inside the 2501. So unlike a layer 3 exchange like the KICS, we don't actually redistribute any routes, so we still like to think of ourselves as layer 2, even though we are meddling a little bit. What this does is it then allows each provider to set up eBGP multi-hop peering over the frame relay router to peer with either other frame relay customers or Ethernet connected customers. So this allows the individual participant to choose who they want to peer with, who they don't want to peer with, and apply specific policies to those peers a little more easily. The design is scalable. GigE would be possible, still be maintained downward compatibility even down to the frame relay level. At this time, no enhancements have been discussed because they haven't been needed.
although when that day comes, they'd have to be discussed and approved by the organization. Traffic levels are pretty boring. They've been staying at around 2 megabits per second average for like the last 2 years, seeing occasional peaks up as high as 5 megabits per second. We don't do any active monitoring, although every couple of months I take a look at the frame cloud and make sure that it's not congested. That is, beyond a doubt, the largest area for potential congestion in the exchange. And at the current rate of growth, I don't think we'll outgrow the Catalyst 5000 for many, many years, several internet decades. We don't do any traffic measurements, so the numbers that follow are total and complete guesses. But having seen numbers from a couple of other ISPs and the companies that I've worked for over the last couple of years, less than 5% of a local provider's traffic is going to route through the exchange, and less than 1%, usually much less than 1% of a national provider's traffic will route through the exchange. And if I had to take a guess, less than half of all the traffic that's on the exchange today is actual local traffic. We don't provide any layer 3 services. We decided up front that we weren't going to do that, but we did and have encouraged local ISPs to offer their layer 3 services, if they have them, to other participants. Here's where our new webpage is located, the mailing list, my email address if you have questions, and the webpage for the Arizona Internet Access Association.
Thank you. No, I need to borrow one of these.
Does that work? Okay. I'm Jeremy Porter with Freeside Communications. We're out of Austin. We sponsored and assisted with several exchange points across Texas, being one of the few providers who is actually willing to go to the effort to learn about these things in advance of the necessity of having them. We put together the Austin Exchange Point about a year ago. It's based on a Catalyst 1900, co-located at one of the ISPs. We convinced one of the local CLECs to provide 0-mile local loops for anybody connecting into the exchange, so it didn't matter where in town you were. We have 7 members signed up, an 8th peer coming online next week. We managed to get the University of Texas system online. We plan on bringing the rest of the state of Texas online as soon as we can get the General Accounting Office to sign off on that. So far it's been 9 months. The University of Texas signed on and immediately, based on their cost of bandwidth, we're operating under cost recovery for their $300 a month local loop. Our main goal was to provide a low cost of entry, as a lot of the providers are, at least on the analog scale, fairly small, and that $1,000 or $2,000 a month peering costs would be prohibitive. We charge a one-time fee of $100 to pay for a port, although probably that fee is going to be discontinued next year, simply because the hardware's paid for. We've got some statistics here of utilization. This is our aggregate statistics, which we're peaking about 3,400 kbps right now, which a lot of our traffic is news. As you can tell, when somebody's news server goes down and the traffic drops by an order of magnitude. Our weekly traffic tends to show the same types of patterns as does the monthly. We've also got a breakdown of this by port. you can see we're plugged into port 1, and you can see that times when our new server is not up and running, the amount of traffic going through there in the blue is a little different. The amount of traffic by peer varies a lot. Since all the providers are essentially connected at T1 speeds, the capabilities of the new servers to send traffic can easily saturate the T1 links, so that somewhat limits the usefulness of the exchange in that way. But essentially everyone is able to send plenty of traffic over the exchange of whatever type. Mostly it's Quake, I think, as that seems to be pretty popular with the university and several of the ISPs connected. That's all the stats on that. We're planning on, one of the providers has volunteered to provide a news peer at the exchange point. However, that hasn't happened yet. And we're looking at providing multicast, but until we solve the bandwidth problem, we're working on a deal to get a better rate for 10 meg or DS3 connects into the exchange point so we can send reasonable traffic levels. That's pretty much it. I don't have the URL handy where all this will be up, but it'll be up on the web page, and I'll send the URL to Stan. So, Dave? Here.
All right. My name is Dave Thomas. I'm with Insync Internet Services. We're a Houston-based ISP, and we decided that there needed to be a place to exchange some local traffic, and it needed to be not cost prohibitive. We currently don't have any entry fee whatsoever. It's just a matter of whatever you want to drop in will peer. We assume MLPA. Bilateral peering, of course, is optional because you have to work out your own bilateral peering. We are using a route server, and we don't have any co-located or any adjunct facilities yet. There's been talk about a news feed. There has been talk of NTP. Right now, the only adjunct service would be the route server, which currently is using RIUSD, but I think thanks to ABA, we will be using the new IRRD. Not a whole lot of traffic going across currently. Let's see, we've got us up here on the top. The majority of our traffic is normally passed to one of our other peers, HalPC, who is currently using the NAP as a backbone connection, one of their dual, or one of their two connections for their dual home connectivity. Right now, they only have one T1. The other three MUX T1s are brought in directly to us, so they don't show a whole lot of traffic. We have FreeSide here, and we are actually passing some traffic back and forth there. A lot of that is multicast, since we do have that DVM-RP tunnel up. And of course, the route server doesn't show a whole lot of traffic because that's not really doing a whole lot, just keeping the BGP up and alive. Right now, we are expanding up to cover full duplex, cover 100 meg via Catalyst 2924XL, and additional memory upgrades for the route server, so we can carry full BGP tables for those people who want to do transit versus those people who don't want to do transit. There's also been talk about experimenting with non-BGP peers, that depending on who wants to drop in bandwidth and actually work with this. Most people are more interested in speaking BGP and peering at a relatively high speed. But that's about it.
Yeah. Here we go. Okay. Hi, I'm Steve Feldman. I work for MCI WorldCom, it says. Oh, down there, yeah, okay. Talking mainly about MayATM, because I've been talking about the other stuff for so long, I'm bored with it. What's wonderful about MayATM? The thing about MayATM that makes it different from what we've been doing before is that it was built to model private interconnects, point-to-point circuits between providers, where they can control the traffic that goes across it, both going out and coming back in. We are doing it with fixed bandwidth reservations. If provider A and provider B want to build a 10 meg circuit between them, that's what they do. If they want more, they can make it bigger, smaller, whatever. The other thing that's different about it is that the customers are going to be provisioning their own circuits as soon as we get this wonderful tool deployed that we've been working on for so long. Based on the web, security, yada yada. The main thing that's exciting about it is that it will enforce bilateral peering agreements. Provider A and provider B have to agree before the circuit gets built. They have to agree on the size of the circuit. And the tool also enforce no bandwidth oversubscription on the switch. So you won't be able to point to us and say that our switch is dropping your cells, packets, whatever. Why did we choose ATM? A lot of people keep asking me that. Can't figure out why. We chose ATM because you can buy it off the shelf today from multiple vendors, switches that actually work, more or less. ATM is nice because it talks directly to the SONET infrastructure. Yes, I'm a phone company. That is important. But that also means that there's no performance penalty for peers who are not co-located in our facility. You can run an ATM wire across the metropolitan area or even the wide area if you really want to, and it will behave the same as if it's in the same room. That's certainly not the case with our city-based stuff. There are upgrade paths available. Vendors are coming out with OC48C capable switches now or real soon now. So when we start out growing the existing hardware, we'll have something to move up to. That's again not the case with the existing platform. And ATM, it certainly has its warts, but we know what they are. Had enough experience with ATM so we can understand what it can do well and what it can't do well, and we know what not to push. Instrumentation, that was one of those questions, so I wrote about that. A couple different things we do. SNMP, basic network management stuff. MRTG, pull statistics off, that sort of thing. Is the switch up, is it down? So our NOC can see what's going on. We're using virtual circuit accounting on the switches to actually look at the individual traffic flows between pairs of customers. For each peering session, essentially, we can look and see how much traffic there is and report that back to the customers. We also have at May West ATM Exchange a Coral OC12 mod box installed, thanks to CADA. And they're using it for a bunch of flow statistics research and other interesting stuff. And my hope is at some point to be able to use it for actually analyzing things down at the ATM level, so what's really going on inside the switch and in the routers talking to the switches. It is installed on a trunk between two of the switches that are there, so we can actually get a good aggregate view of what's happening in the middle of the exchange, which is something we've never really been able to do before. More instrumentation stuff. Since we're asking customers to manage bandwidth, we thought it would be only fair to tell them what they're actually using. So I've built a tool that collects the VC information and puts it on a pretty web page for them. At some point this will be integrated back into the provisioning tool, but that's in the next phase. And if you want more information on the instrumentation at the maze, also on the city stuff, there's a paper I did for a meeting a couple months ago. There's a pointer to it up there. And here's the usual contact page if you want to talk to our marketing people for whatever reason. info@may.net works. There's me. www.may.net is the unofficial May homepage where the useful information is. And this presentation will be up somewhere. The official one, as far as I know, doesn't exist yet. Anyway, the presentation will be up there. I'm sure there'll be a pointer to it from the notes page for this. And I think that's everything except one last thing I can show you, if I can see it down here, is this one? Okay. This is an actual graph of traffic going through the Midwest ATM platform ending this morning. We're peaking now a little over 200 megabits per second, which is roughly 1/10 of what's going through May East right now. And that's probably with about 6 active peers right now. That's that.
We need to switch something here?
You have a function key or something that you can...
And then you look down there.
Oh, cool stuff, though.
No jokes.
No jokes was the rule. But we have a couple minutes. We're running ahead of time, though.
No jokes. This is serious.
This is serious stuff. Okay. Well, when I spoke with Bill Manning about what Equinix is doing with the CGIF project, which is the commercial grade internet facility project, he suggested it might be good to just give you guys a heads up as to what's all going on with this thing. So, the basic notion here, is there's a mission to see if we can help harden the facilities, the internet facilities. And there's not a whole lot, as your T-shirt shows, that we can do about the backhoes, except maybe give them rubber shovels or, ban them somehow. We can't do much about the links. But what we can do is focus all of our attention on making the physical facilities for the internet a whole lot more robust. So that's really what our mission is try and help harden the internet. So one way to do that was by seeing if we can find some folks to actually fund the mass deployment of a large, very large number of really solid, robust internet facilities across the nation, around the world. We have venture capitals, funders who have a real interest in making sure that the internet continues to scale and grow and be rock solid. Since we're talking about something where millions of dollars is going to be transferred over the net, they have a real strong interest in doing that. So a couple of things that we've been complaining as a community about have been how some of the facilities providers don't understand the IP stuff. You call them up and they say, what's your circuit number? And you say, I can't get access to my router at your facilities. They say, what's your circuit number? And you have that sort of disconnect. So what we're trying to do is put in place a large number of these facilities that have staff of IP clueful folks. And again, we're talking about some fairly large sums of money going into this company to deploy these facilities from the interested parties. We're talking about between 40,000 and 100,000 square feet facilities. And to give you an idea what that is, Stan Barber and I were just sort of figuring out how big this room is. This is probably about about 10,000 square feet, about 100 by 100. So a facility is about 4 times the size of this on the low end, growing to about 10 times the size of this room on the higher end. So some pretty large facilities here. And again, the number we're talking about over the next 2 years or so, 2 or 3 years, we'll be between 35 and 40 globally. In the next 5 to 6 months, we're going to have probably about 3 located on the East Coast. I think the first couple are going to be in Washington, D.C. and New York, with other ones perhaps in Miami, perhaps in Seattle. We're still trying to get the final leases and stuff signed for that. I don't know if you can see these globally, but we're talking about a whole bunch of these going on into the Pacific Rim, 4 actually going into Australia. The details, again, of some of the global ones are so far out, probably about a year out or so, that we can't get into the specific details, but we are looking to work with the community to figure out exactly where we ought to have these things located, because this is really what our charter is. As far as rules of engagement for these things,
we're really coming at this from a policy agnostic standpoint. That is, we're talking about facilities so large that we're imagining you could have actually multiple NAP facilities running in it, perhaps run by individuals, perhaps run by consortiums. We heard of a number of folks here that pooled interests together to operate things. What we want to do is make sure that whatever facilities go in place, whatever co-location requirements are there, if you have folks who are looking to have a point of presence, a lot of times the last thing people think about is adding UPS into their facilities. We want to make sure that the facilities are rock solid, and we want these facilities to be used. So we're taking a policy agnostic standpoint in terms of what folks can do in these facilities. And a couple of other things. I think, Dave, you brought up the notion of a not-for-profit running these things. We also have heard a lot of ISPs say that they're concerned about who's running the physical facilities and who's doing the settlement and brokering types of things. So we are not an ISP. We don't operate a telephone company. We don't expect we're going to be acquired. That kind of stuff is not in the cards. So we're working, again, very much in the analog sort of tradition of trying to pull together the interested parties, the ISPs, the content providers, and so forth. I highlighted a couple of value-added services because I think one of the things we're going to be working on quite a bit will be the notion of peering and settlement. I'm not going to talk about that here, though. In terms of technology, again, sort of imagine there's going to be multiple exchange points, multiple types of interconnects between various folks. So we're sort of imagining there's going to be multiple disjoint technologies. We're talking with some of the terabit router companies to see if that might be the right way to go, switching at OC 192 sort of levels. But at this point, we're really looking for some feedback from you folks as to what you think the appropriate technology is. I don't want to talk too much about a couple of these things. Yeah. Yep. Yeah, and the last thing I wanted to mention, again, this is just sort of a heads up to folks. There's going to be a BOF tonight. Jay Adelson is, as we speak, working day and night on getting new facilities put in place. And what we'd really like to do is see if we can share that information back to folks. So if you're not going to use some of the facilities that these folks are using, we want to make sure that the facilities you are putting in place for your points of presence are rock solid. So we want to share the information that we have so far. Sean Donlin and Justin Newton will be doing the same, providing some feedback, because there are a whole slew of trade-offs in your own internet facilities that you're going to have to go through as far as raised floors, backup power, AC and DC, and so forth. And we want to make sure that information gets on the table. And the hope for the BOF tonight is that we come up with a recommendation or some documentation that folks can share and use for constructing their own points of presence that are rock solid. That's basically what I want to do, just sort of raise this up on the radar screen. And this is coming up in the next 5 or 6 months.
Done?
That's it.
Okay. Don't go away. A couple of closing comments, and then we'll entertain Avi's question, and maybe anybody else if they have some. Internet exchanges run the gamut. I think we've seen some of this today. They can be as simple as an intellectually challenged piece of media. I think the earliest exchange I saw was a piece of yellow coax, which dates me, to some fairly high technology stuff. Not every type of exchange will meet every type of service provider's needs. And what we didn't talk about today, and what you ought to consider, is your migration strategy. As you and your business grow, when do you need to consider leaving an exchange and moving on to a different type of exchange for your traffic? I mean, that's important. And how easy it is to do that kind of thing. So I'll leave it there. I'd like to thank the various panel members for sharing their experiences. And Avi? Are you placeholding for Kathy?
No, I wondered if he had my question, but he didn't. So I have a question for Bill. Can you talk about what your plans are for telco entrance facilities in your facilities that you're building?
I would defer that question to Jay.
can either answer the question now, or you can tell her to come to your boss tonight. Pick up some of your crap.
Oh, okay.
Yeah, and feel free to if anyone has any questions about the technical aspects of Bill's discussion, to see me privately and be happy to answer. But just to answer your question, telcos are participants much in the same way at the Palo Alto Internet Exchange that a lot of us come from. So if you have questions about carrier entrance, multiple fiber entrances, vaults that are built by Equinix, multiple fiber providers, you've probably heard it before. So. This is another Equinix question. There's a local bank in Philadelphia that promises if you sign up by the end of the year, they'll give you $1,000 if they're bought by the end of the year 2004. Does Equinix plan to do anything similar? Or promise free transit if they become an ISP, or if they are bought by an ISP, or to contractually say that they will remain independent and not start offering IP services? Or is that for someone else?
This grasshopper walks into a bar.
The Dalai Lama goes to a hot dog vendor and says, "Make me one with everything."
This one's better, I think. Let's see. A grasshopper walks into a bar, and the bartender says, "Hey, we have a drink named after you." The grasshopper says, "You have a drink named Steve?"
Mine was better. Now answer the question.
I can't answer that question.
Okay.
You have any other questions?
Avi, I can answer the question. If Equinix is bought, then you get the bank in Philadelphia, Equinix, whatever. One of them E words. If they get bought, get the bank in Philadelphia to give every Nanog member $1,000. Okay?
I will say this. It's not in the interests of the investors of Equinix for currently, yes, to be purchased. The neutrality premise behind Equinix is really the whole purpose of the company, is to stay neutral. And I don't believe that our current business plan could function under the sole ownership of any organization. Also, the cost of purchasing a company like Equinix would be fairly high, and most of the qualified parties are telecommunications, right? And that would compromise the neutrality immediately. So I won't say we have a poison pill, but we have designed the business very carefully to discourage that.
It doesn't work anymore? That's because Bill used it.
Does this work now? At the beginning of your presentation, you mentioned that one of the things you were trying to protect against was backhoes digging up fiber. Can you tell me exactly how all these facilities that you're building protects internet providers from their telco vendors selling their Protect systems? Sure. How does this solve the problem of fiber cuts by having all these facilities that you're building?
It doesn't. No, the basic idea is that there are two things, right? You've got links between facilities, and we can't do much about protecting the links. We can't ban the backhoes from expanding and digging up sidewalks and things like that, but what we can do is harden the facilities, but make sure that as many points within the internet that have services that are important have a rock-solid infrastructure. And then the links will be sort of the next thing we've got to target. Hopefully people are digging once and then they don't have to dig again, but it's kind of hard to... Like 640K is enough memory, no one should need more, right?
One of the things that I always found is that when your external links disappeared, even though you still had the local connectivity, is that you couldn't get access to the DNS server, so a lot of times your local access disappeared anyway. So DNS might be something you want to consider.
Sure.
There are no urgent DNS problems.
Actually, Dave, back to you, I had a question for you. You talked about some non-BGP traffic and some interested parties doing that kind of thing. Maybe you could say a few words more about that. Are we talking about transit then, or are we talking about pointing default?
Well, does this work? Okay, this does work. Okay. The intention was to use private AS to announce BGP or to announce routes into the NAP fabric on behalf of statically routed non-BGP speakers. You have one router that speaks BGP on behalf of whoever, be it one person, 10 people, 20 people behind there who don't want to speak BGP or who are not capable of speaking BGP or just don't know how.
As long as the panel is asking other panel members questions. John, this one's for you. When can I get rid of this extra switch fabric bag on the side for multicast and just run over the same switch fabric? Because I really don't like the bag on the side.
Yeah, I don't know. That's a good question. I mean, ideally, what we'd be able to do is run multicast and unicast congruently over the same infrastructure. But there are still some issues to resolve in multicast forwarding and routing through a switching fabric. So as soon as, certainly at the interdomain space. So good question.
Okay.
Listening to this, I've been struck by the immense range, I guess I'd almost call it the business plans, from folks who basically can work as don't charge for everything, donate effort and time, and it all works for our benefit, to folks well funded by venture capitalists who, in my limited experience, rarely did things from pure altruism. Do any of you have a feel for, is this sort of melange continuing indefinitely? Are there some definite trends to how access points, as a viable entity, are going to move or grow?
Start down there.
I think the trick, at least for me, was realizing that there is no one-size-fits-all exchange point, and you really have to define what your market is and start building to meet those needs, and not try to meet the needs of everybody on what you consider the extremes of what your model is. There are other people who can do that quite capably, and you should focus on what you're good at.
I believe there was a discussion on Nanog about, a year or 2 years ago regarding the total number of exchange points there would ever be. Some people said, on the IBM theory, we'll never need more than 10 in the world. A lot of other people felt that there may only be 10 really large ones for various reasons, or there may be some subset that are the largest by several orders of magnitude by traffic volume. However, the benefits are real easy to demonstrate once traffic volumes get to 4 or 5 megabits on the local side, and when end users start having DSL connections for local traffic, then that becomes pretty obvious what kind of traffic levels the small exchange points are looking at in the near term.
Ditto.
Something works. As long as there are thousands of ISPs in this country, there's going to be a requirement for people to get together and work out problems to solve capacity issues. And I don't think it's really an issue of people getting together to build an ISP or an exchange point, or going out to other exchange points to exchange traffic, and the technologies in use and the models in use for the exchange point. People are going to do whatever they have to solve their connectivity issues and to get the performance that their customers are asking for. And depending on where you're located, you're going to do whatever it takes to do that. So the evolution of these exchanges is going to depend on what happens in the internet. And most of us are just trying to meet today's needs and the needs we're going to have 3 months from now and 6 months from now, and a year from now we'll worry about in 6 months.
I think, Bill, one of the things that I see is there's a whole class of internet service providers that we don't see at Nanog that may be well represented by my 15-year-old son and his friends. They're doing exactly the same things that a lot of people here did. He's got a couple of fairly low-end machines, and he's managed to persuade me to buy him 3 telephone lines, and he's got a profitable business selling internet services to about 25 of his friends. In that class of people, some of the early designs we've seen for internet exchanges tend to work fairly well, where their traffic requirements don't need gigabits and terabits worth of switching capacity. They don't really care that they have, 365 by 7 by 24 availability from 9 different telcos through hardened facilities. They could care less. They want to be able to do their gaming. And so the designs that we've had and we've seen, I think that they will still have a place. They will continue to have a place in the market that Nanog has. And some of the designs that have been talked about are more applicable in other places which are not so prevalent, particularly in North America. They may be more applicable in Central America or South America, where the telco infrastructure is not as does not reflect the North American model, or where there are topological limitations, such as Southeast Asia, where you can't run glass between 100,000 islands. So it's another tool in the toolbox. If there are no more questions, how are we doing on time? Craig? I'm going to hand you the baton. This mic doesn't work anymore. It will?
Yes, yeah, interesting. Okay.
Okay, well, thank you.
Okay, well, we have a few minutes yet into the break, just a few odds and ends. If you do have any problems with the network, any questions, please do not send the question to Nanog. The ones who can help you are nanog-support at Merit Edu. So most of the list, most of the 6,000 people on the mailing list will not know the answer. Nanog support is the right place. There were a number of questions about where the beer and gear is, or specifically where the beer will be tonight. The answer to that is on the 10th floor. All of the elevators go there, apparently. I don't quite have this hotel all figured out, but all the elevators go to the 10th floor. It's called the Skyline Lounge, and there will be lots and lots of beer. So that, yeah. And yes, and there'll be some vendor stuff. But I should add, too, that I kind of have mixed feelings about this beer and gear thing, that we generally try to discourage large, glitzy vendor sort of displays at Nanog, since there's lots of places for that. I went to Interop in Japan, and it was great. There was, women in short skirts. Well, I won't go there, but it was models and glitz, and Nanog really has a sort of research and education roots with the NSFNet, and for the most part, we're trying to stay true to our roots. The beer and gear philosophy, however, is that we really wanted a social period, and we didn't know how to fund it. So we really wanted the beer, and we figured if we kept the gear low-key, we could get the beer. So other than that, we really do try to remain sort of vendor neutral and not have a large presence. I'm trying to think if there's anything else I should, explain, well, what mics? Susan wants to explain here.
Yeah.
Okay.
As the speakers come up later, especially for panels, the people in back are carefully watching what's going on up here. So as a person opens their mouth to speak up here, the mic will magically know and will come on for you. So just look eager and everything will work just fine. And also, speakers, when you're up here and you're using your laptop here, look down at the screen rather than up. Then your face will be towards the audience. The screen is showing, these are the same. So look down just to check your signal.
Thanks, Susan. And the last audit, if speakers do have slides, please mail them, not to Nanog, but to nanog-support, and we'll put them up on the web, hopefully as the talks go on. I think we've had a number of volunteers suggest how to set up the wireless backbone, so we're going to try to make it up to the 10th floor. We'll see, but hopefully we'll have that working today. Also, those folks in the back of the room who are sitting on the floor, you'll have to move. We're putting some more tables back there so you don't have to sit on the floor. So during the break, they'll be coming in with tables, and please make sure the aisle is clear so they can actually move those tables in. With that said, I have nothing else to say. The food, yeah, so we'll break now. The food won't all be delivered for another 15 minutes, so we have a little period.
Start again at 11.
And we'll start again, thank you. And we'll start again, oh, wait, hey, I'm not done yet. And we'll start again at 11.